All right, everyone. Great to be here with you. I want to thanks for everyone for gathering, and great to be great to be convening the Retrieval Markets workshop. What I want to talk about today is these four things. So just quickly touch on the Retrieval Markets working group and the workshop. Patrick already gave a phenomenal intro to the Retrieval Markets problem and the working group and so on. I want to focus most of the time on this rapid-fire updates across the ecosystem that can help all Retrieval Market groups integrate some of the information that's happening. So there's a ton of progress across the ecosystem on many kind of fronts. This will be useful for the people actually building the tech to be able to kind of tune their approaches based on the other opportunities that are happening in the landscape. And then from that, I want to then kind of have an open discussion about the Retrieval Markets landscape in 2022 and various different opportunities. And from that, narrow down to some set of network goals. So the last two sections will be more conversational. So want questions and so on from the group here or on YouTube and so on. And then from that, I want to kind of like propose a very concrete network goal that we should hit basically as fast as possible to kind of unblock a bunch of the kind of open-ended innovation that I think many other groups in the ecosystem have gotten to. Great. So kind of in short, the objective of the Filecoin Retrieval Market is to build the world's best CDN leveraging Web3 tech. So it's not about just building the best CDN in the Web3 world. We want to really build the world's best CDN leveraging the Web3 tech underneath the hood. So we can leverage content addressing, crypto incentives, verifiability, permissionless networks, and markets to build a massive scale cloud CDN that should compete and beat the centralized providers. Kind of a shorter version, a kind of like intermediate target building towards that is to build a worldwide, fast and efficient CDN for IPFS content. So you can use that as a stepping stone on the way to building the world's best CDN. And so if we focus on the second goal as an intermediary goal, we can get to the first. There's been a working group effort around building the Retrieval Markets for a while. I won't go into in depth there because Patrick already did a phenomenal job giving us an overview. I want to kind of point out a set of goals that I think we should be aiming for. We should be aiming for a network of about 10,000 plus devices at minimum, so that ideally hundreds of thousands and millions. But just getting a network up of tens of thousands of nodes would already greatly improve the setup. Then from there, getting to thousands of people, thousands of individuals involved in retrieval mining. If we can get to that as fast as possible, so say in a quarter or two, that would be that would kind of unblock a lot of the innovation. And then if we can establish less than 1 second on average for delivery of any CID across all content, that would be transformative to the whole IPFS network and the Filecoin network. So right now, retrieval is a big bottleneck for a lot of use cases, as I'll go in detail in a moment. And so if we can just get to the point where for most retrieval queries for any CID worldwide, users can get a less than 1 second retrieval, that would open massive amount of adoption for all of IPFS and all of Filecoin and other networks, and then very market into something really big, and help Filecoin and the broader IPFS network achieve a lot of goals. So let's start with like a very, very concrete problem space of not 10,000 nodes is not that large of a network. We can totally do that. 1,000 people plus, not that hard. We can totally do that. Less than 1 second of delivery for CIDs worldwide. That's harder, but we can do it if we can focus on the things that are requested most. And I claim that there's probably somewhere between 1 to 10 petabytes of hot content. That's what we need to distribute. Great. So this workshop has just an introduction to the Retrieval Markets in general. Then we'll have a section talking about Filecoin Saturn, and we'll hear from one project. And then we'll have an open discussion, especially around crypto econ and various different approaches. So there's a lot of content already about kind of like why Retrieval Markets in general. There's a set of videos that you can look at on YouTube. There's a Filecoin.io explainer. And there's awesome content being produced through the Retrieval Market Builder demo days. You can go look at those and see all kinds of progress across the network. There's also a bunch of really good YouTube videos. In short, the kind of like the crisp view of this is that the internet is a grapevine. Content must flow through these very crowded branches to the leaves. And you want to create open-ended protocols that enables any participant around the internet to spot an opportunity to deliver content, leverage content addressing, and provide the best possible delivery of that content. The centralized cloud already kind of does this a bit with large storage networks and CDNs, but you can do way better if you make it open and permissionless. Right now, all kinds of groups that are in a great position to add a content cache very close to users and where the user demand is can't do it because there are all these private networks that are centralized and prevent their participation. So think of being an ISP or even like a cell tower operator or something like that. And there's all kinds of traffic flowing through that network, oftentimes the same kind of content, the same movies and so on. You could totally deploy a content cache right there to provide content to the users. But you really need the content flow to move into a content-addressed model of the world. And you need to be able to join a network that lets you kind of participate in that way. So that's why the Filecoin Retrieval market can greatly speed up the CDNs of the world. The way to sort of like map storage providers and retrieval providers to the traditional cloud is to kind of think of this sort of layout where you have storage providers in the center, and then you have the retrieval providers sort of as a cloud around them, which, as you'll hear from Saturn, like maps well to why the project name is that and so on. You should think of storage providers as coming in many different scales, from just a few set of drives and so on in a home to kind of like small racks to very large operations with full data centers. And we already see this across the network. There's massive scale storage providers with, and there's also a ton of smaller scale storage providers. So the data is finding its way to really great homes across this network. Now we need to build out the retrieval provider network. This will tune better for smaller devices and smaller deployments that are much more evenly distributed around the world, close to where people want to retrieve the data. I would add this is not in the explainer, I need to add an image for a mobile device. I think that mobile networks can also be good for retrieval, but it's actually a much harder problem. So I would not encourage groups to kind of start with that because getting retrieval CDNs and so on in mobile is way harder. But if you sort of target like home machines and maybe one single machine in a data center, or potentially like a full rack, that's about the size of what retrieval providers that I think will be really successful. The smaller home machines, of course, will be way more of them, and that will be kind of extremely useful to store data. Less so to serve data at really fast speeds. Smaller deployments sprinkled in internet interconnects. So there's all kinds of data centers that are where there are kind of terminals where lots of different cables and so on and different organizations peer with each other. Those are great spots for one of these like larger caches that can do a lot of has a lot of bandwidth capabilities, or ISPs. So any kind of like either hardwired ISP or a wireless ISP. Those are great places to deploy these kind of one single rack of drives, for example. Just for clarity, the retrieval market kind of operates off-chain, so you can use the blockchain to set up a bunch of the transactions and to lean on payment channels or identities for providers and so on. But all of this operation has to work off-chain, and you have to get delivery to be extremely fast and with very low onboarding costs. So you can't create a structure where like the end users and consumers of some content have to have some like onboarding hurdles that prevent them from accessing the content. So I think those kinds of approaches will be harder to make work. Very possible, but harder to make work. And one of the images that I want to kind of leave everyone with is like really try to solve the kind of speed of light problem. So a key component in all approaches has to be how to reason about how the requests are coming into the various machines and route those requests to machines that are close to where the users are, and try to push content as close as you can to where it's being requested a lot. So over time, over the long periods of time, you can gain predictability over what kind of content gets requested where and so on, or have an adaptive network that over time moves the content to the right spots. This is how modern CDNs work. But decentralized networks and peer-to-peer networks and blockchain networks especially don't pay close attention to the hops going around and where people are kind of requesting things from and so on. And this is not something that retrieval markets can, that's not a luxury we can take here. We have to be very, very precise with which machines every single request is going to go to try and shave off tens of milliseconds at a time. That's how you get to extremely fast retrieval. So if your approach, as you're thinking about it, has any kind of open-endedness where a user request might accidentally hop across an ocean, that's not a good approach. Redesign. Like, really, you want to be extremely careful to make sure that users are able to kind of plot their retrieval pathway to nodes that are going to ideally have the content, ideally in their closest data center possible. Now, of course, that won't always be the case. You want to kind of like fall back gracefully, but you want to kind of exploit the landscape here to minimize the speed of light distance and minimize any kind of round trip and so on. Also important here, any kind of protocol that requires full round trips to operate, also problematic. You want to get to a spot where, as the round trip is going, as the request is going out, you can get the data back and be very, very careful about round trips. You can afford round trips when you're going close. So for example, you can afford round trips when a client is talking to another node 5 or 10 milliseconds away. Like, that's not a big problem. A round trip there is OK. But if you're dealing with round trips with hundreds of milliseconds, your host, do not do that. So that means, like, be careful in the choice of crypto, in the crypto handshake and establishment of encryption and so on, because usually those protocols introduce a bunch of round trips, and like they kill you. They kill your retrievability. So lean on things like noise and so on, and lean on routing end user clients to nodes very close to them, and then from there proxy over the request over an already set up channel to be able to kind of minimize the setup latency. So modern CDNs like Netflix and others, for example, have these like persistent connections where your client, when it wakes up, immediately connects to a set of nodes that are very close to them, does the connection setup, and from there we use that channel to not have any kind of like additional setup times for any further requests. You want to exploit these kinds of techniques to avoid putting users in a position where like they're routing around and talking to dozens or hundreds of machines, and each time setting up new crypto handshakes. Like, that will totally kill any kind of retrievability speed. So here we want to kind of shave the latency down as much as possible and get to, again, tens of milliseconds in the best case, hundreds of 100 or 200, maybe 300 milliseconds in the kind of like average bad case. And of course, in the worst case, when the content is not hot or something like that, then you get into 1 to 5 second retrieval or something like that. But that should be very much the exception, and for very, very few cases. So this is non-trivial, right? So like doing this really well is hard, and doing this in peer-to-peer decentralized networks is way harder because most approaches are totally ignore speed of light, totally ignore reuse of connections, totally ignore crypto handshakes, and they just sort of assume that you have the capability of connecting to a ton of nodes in the network, and that you're, for privacy or security reasons, you're fine with that. In reality, the modern web and all video viewing will not move over to decentralized networks if that's how we operate. We have to totally shift the behavior here so that end user clients spend as little time in connection setup, and then from there can make extremely fast requests. So again, latency in the kind of like best case, we need to make 1 to 10 millisecond retrievals possible, and kind of get the norm to be kind of 50 to 500 milliseconds. Also, something that complicates this, the number of objects is very large. When you think about hundreds of petabytes of content, those hundreds of petabytes will have tons of little pieces of data, little files, little data structures, and so on. So you have a lot of objects that people want random access to. So you need to be able to do routing towards these objects quickly. You can exploit all kinds of things there to be able to amortize the lookup costs or do predictive lookups and so on. It's a whole other problem for another time. At the end of the day, we again kind of want to have, you need to have a network that has hundreds of thousands to tens of millions of nodes. Like that's kind of the where we're headed. I won't go into detail here. This is kind of well covered in a bunch of the other videos and so on. There's a lot of great tools and tech at our disposal. There's all kind of components that a lot of us have been building for 5 to 8 years now. And there's this broader approach that we're taking of really tuning for typical CADN product experience and aiming to build a profitable and easy to run retrieval provider software and aiming to kind of wire those components into really good products. Cool. So I'm going to give you some rapid fire updates from some other groups, and then we're going to kind of talk a bit about landscape. Although I'm looking at time, I may. OK, cool. Thank you. Thanks for the extra time. So this is kind of a map of the Filecoin ecosystem right now. Sort of made this relatively recently, or the Filecoin broader kind of data system. The ecosystem is larger and includes a lot of other participants and so on. This is kind of like a zoomed-in view to the data flow. So think of kind of the data starting with the storage clients. That data is usually kind of associated with some use case or some pattern, and the end users of that use case or the developers of that use case will want to tune the access pattern and will want to tune the onboarding flow and so on to that particular type of data and so on. So that means that these sort of data on-ramps become extremely useful. These are services like NFT storage, Web3 storage, S3, Fission, Fleek, and so on. You can think of those as use case-specific applications that tune the interface and tune the parameter space to fit the data access patterns for that particular type of data. So you can think of like the interfaces that Filecoin provides as lower level infrastructure, lower level plumbing, and you can think of the developer on-ramps and so on as a specific kind of like use case porcelain tuned to a particular data flow. So that's working super well, and each of these on-ramps is scaling significantly, and a ton of usage is coming in through those systems. So we'll see it in a moment. That and kind of like the data onboarding pipeline is very large already and growing. So I think we'll see it in a graph in a moment, but we have days where like more than 1 petabyte of new data is added in that day, and the average is around somewhere between kind of around half a petabyte a day, which is enormous. For context, the rest of the Web3 space is kind of like somewhere between 2 and 5 petabytes. So like we're adding way more content to Filecoin in 1 week than the rest of the Web3 world has in total. And that means there's all kinds of users coming from Web2 and from other more traditional approaches that are starting to use Filecoin. Now, that data today is not retrievable quickly. It's pretty slow and spotty and so on, as we saw in the last talk. One key piece that was missing was the ability to do indexing. So SPs were not advertising all their content into the IPFS DHT because that would be horrendously slow and a huge burden. And a new network indexer has been deployed in the last few weeks. And that indexing service now can index all the content from the various storage providers. So just right now, something that wasn't possible a few weeks ago is that now retrieval networks can lean on that indexer to find any and all of the content stored on Filecoin. So great opportunity to then create these kind of retrieval provider networks that can take a user retrieval request, look up in the index quickly, kind of like in an O of 1 access pattern, where to go get the content, and now provide it to the user. So we're now kind of finally in that spot. And so the dev on-ramps are working really well. Now what's not working well yet is the retrieval provider networks. We need to greatly improve that. The one that's most used today, you can think of the IPFS gateway and the IPFS spinning services as the kind of like best retrieval networks today. And we want to do way better than those. So we'll zoom into this model a little bit more later. For context, the number of SPs globally is scaling. There's growth in a ton of places in the ecosystem. This is kind of like a chart of like Filecoin Plus, which has been extremely useful in scaling up data usage and so on. You can see the graph in the bottom right of the amount of data being committed daily to the network. The y-axis is in terabytes, so like the top is like 1.2 petabytes. And that, that continuing, all of that data needs fast retrieval. So as I'll cover some use cases in a moment, and all of those are hurting for fast retrieval. So NFT storage, has on the order of like, it's about to cross 60 million NFTs, which is huge. It's a ton of individual objects. People want really fast access to those NFTs. And good news, they're not that large. When you think of all of those put together, it's not actually that big of a data set. So that could be replicated in a ton of places and served very quickly to end users. Web3 storage is a similar kind of developer on-ramp that also has a ton of data flow is growing at similar scale to NFT storage, and all of those objects need random access. You can think of like other large-scale clients and onboarding funnel. There's a ton of different groups that are in some stage of a trial of Filecoin. Like some users are early, they're finding out about it, and so on. Others are kind of running proofs of concepts in the moment. And in all of those conversations, retrieval becomes a big point. And so there's a ton of providers that want to make sure that they can retrieve their data and so on. The access patterns will vary. So some of these are large data users that when they retrieve something, they'll want terabytes. Like they have their own local operations. They're using these networks for archival or long-term storage or resilient storage. And when they retrieve something, they might want full terabyte drives to be sent to them and so on. Though that's not the norm. The norm is that people do want kind of random access to their objects. It just depends on what object size. In some cases, they're small, like kilobytes to megabytes. In other cases, they're like gigabytes. So think of video storage users as wanting access to many gigabyte files at a time. So again, NFTs are growing a ton. Metaverse and games is a big one. These are very much rate limited by retrieval. Mona is a great example. They're a platform that enables anybody to make metaverse rooms and whole spaces, and then sell them as NFTs, and then wire them up together so you can explore, go into one room and jump into another, and so on. Each one of these objects is gigabytes in size. So when you, especially the higher quality ones that sell more because they're like much more beautiful, are way bigger. So like the textures are pretty big and so on. Plus then all kinds of techniques that you might use to kind of do faster loading in the client side, blow up the data size. So if you want to do like careful texture resizing and so on, you end up with like a larger overall size of an asset. So this needs really fast retrieval for the end users, especially if you think of like exploring a space that has a lot of links to many other rooms, and you have to sort of preload the other spaces so that when you walk around a corner and you enter another space, that other space has now been loaded and can be stitched together cleanly. Right now, if you hop into a Mona room, you're hit with a progress bar where like the majority of the weight there is loading, just downloading the thing. So that's kind of like a very concrete problem to solve. And there's going to be a bunch of other new kinds of NFTs emerging. So I think video NFTs are around the corner. They also need really fast retrieval. Filecoin, now called, I think, Vivid, and Livepeer are going deeply into this. Those tools just got deployed in the last quarter or two, and they'll follow a pretty fast growth rate. I would expect that within 2 to 3 quarters, we have millions of those. And they'll need really fast retrieval. And then there'll be other kinds of NFTs that emerge too. So when you think of like spaces like these, think of being able to create full experiences within those environments. It's not just a space. You can like program the space to have a game or have some other kind of artistic experience. And that kind of stuff is probably maybe 3 to 4 quarters out. So I would expect like next year to see a lot of kind of like the combination of 3D spaces and art, where you have like full experiences being developed and sold as NFTs, and those will need super fast retrieval. So a ton of opportunity. Just in general media and so on, of course, like video and audio are huge. The vast majority of the internet traffic on the network is video, on the broader internet, I mean. And so being able to tune the retrieval market to serve video extremely well and better than other networks, faster than other networks, and so on, is like a really, really great direction. So I'd sort of expect some of the retrieval market networks to evolve into a spot where they can deliver this video extremely quickly. There are other uses which have a lot less data but require a lot more random access. So things like individual, personal file storage, and so on. There are a lot of these systems already, and there are some set of retrieval networks are going to tune for these. The benefit of these ones is that it's not that much data. The files are really small, and you can cache them everywhere. But it just sort of tunes your approach to deciding where to put stuff and so on. Because here, like, you have like a very long tail of files that you access very rarely. But when a user wants to access them, they want them very quickly, right? Like you jump into like your personal file storage thing or your team's file storage thing, and you want to be able to search for a specific file, and you want that file to come up in ideally less than a second. But it's very long tail of files, and it's very hard to predict exactly which files will be used. And then there's a whole bunch of other really cool data sets that people are putting on Filecoin already. Large-scale data archives, including things like the Internet Archive, where the Internet Archive itself is like doing a pilot of putting a large chunk of data into the Filecoin network. But imagine being able to, we can actually host the entire archive many times over. The whole Internet Archive is, I think, on the order of like 60 petabytes or so. So you can like have that many times over and be able to provide fast retrieval to all of it. There's all kinds of other large-scale data sets and so on that are going to come in time. One opportunity for retrieval markets here is that there are several browsers that now have IPFS support. So Brave ships with a full, Brave works with like a full embedded Go IPFS node. There are others like Opera and so on that have kind of gateway usage. Those are prime candidates for Filecoin retrieval markets because, especially something like Brave with BAT, you can hook up the user's BAT wallet to pay for the retrieval of the content directly, and like that would actually close the loop and do kind of like the old, even 1960s vision of hypertext, where like the actual user is paying for the retrieval of the data as they're viewing it, and that would be pretty cool. But again, anything that sort of like requires user onboarding on a per page basis won't work. This has to be completely automated underneath the hood from the users, like BAT wallet, automatic swaps with DeFi, and then paying for the retrieval. Yeah, here's like a view into the network indexer project. I think this blog post was last week, so you can go check it out. And that kind of like really closes this really important loop here of being able to kind of index all of the content to be able to retrieve it quickly. The last thing I'll mention is FVM. So FVM is around the corner. This will add smart contract computation to the Filecoin network, which will bring a ton of smart contracts into it and so on. All of those will need, a lot of those need access to data. And that will also create the opportunity for compute over data, which is a whole other set of things, which is you're able to kind of orchestrate and organize large-scale computational pipelines around the data on Filecoin. So think of large data having gravity. You bring the data onto Filecoin, think of large-scale data sets and so on. Then you want to run computation over that data. So you want to ship the computation to wherever that data is. That's less of a use case for retrieval, because in that case, you're trying to move the computation to that data. But that is likely to generate a bunch of results that are way smaller than the original data that do need very fast retrieval. So that'll likely generate, all the compute over data stuff will likely generate all kinds of intermediary artifacts that need to be retrieved quickly. Great. So so that's kind of like an update view across the whole network. So let's now kind of talk a bit about the retrieval landscape in 2022. So going back to this model, we need to boot up these retrieval market networks that try to localize regions to fight the speed of light. So the way I sort of think about it is like being able to create a bunch of different small subnets mapped to a specific region, and the size of this region, we can sort of start up with the region size that the cloud, centralized cloud has built, which is kind of like somewhere on the order of 5 to 20 regions in the world, and then subdivide from there as we need. And we kind of want to lean into leveraging the fact that there's two basic problems. One problem is how do you deal with the massive amount of requests that are going to come from retrieval clients? So how do you deal with the tons of connections and initial connection setup, which introduces latencyy and so on, and deal with that level of bandwidth and provide good user experience, especially to phones that you want to have really, really fast access, and you don't want the phone to do a lot of stuff. And then on the other side, how do you do the routing of the request to find where it is and fetch the data and ideally preload it into a region? So think of it like solving two problems. One problem is how do you handle the bandwidth and the large scale of the connections? And then how do you either preload or go find and cache the data quickly to kind of serve it from within that region? And I think that sets it up well for Saturn, because I think Saturn will talk about this. The broader picture, though, is like there are many different use cases and several different economic models. And because of these use cases and economic models, this will necessarily mean that it will be different retrieval networks with taking different approaches. And that means like different software distributions, different content, all that kind of stuff. We want to create an environment that enables those different retrieval networks to boot up, run, and so on, and interop as much as possible. And if we can lean on kind of payment channels and so on, and a very common interface on how to retrieve something, that could actually even allow interop between these networks. That I sort of see that as like a maybe late this year or probably next year type of problem. Let's first kind of work on booting up these networks to get to serving the kind of most common 1 to 10 petabytes of content around the world, around the network, and preload that into everywhere around the world to then be able to serve that extremely quickly, and create the networks that enable onboarding of a lot of people in those regions to be able to provide nodes to be able to serve in those areas. Cool. I will stop here. Any questions, thoughts? Yep.
Has PL spoken to the Internet Archive to explore the big loud talking stick? Has PL spoken with the Internet Archive at all to explore accelerating the Internet Archive with any of the retrieval market products? Is that something that's been
so I think
explored?
Right now they're working on a pilot to store the archive. Retrieval right now in Filecoin is slower than the Internet Archive, so once we have faster retrieval, then we can do that. But build the tech first, then do it. Yeah, but yeah, that's a very good data set, and there are on the order of 50 to 100 other data sets that are in various stages of like being identified or contacted or already in proof of concept, onboarding onto the network that need that kind of accelerated retrieval. So yeah.
Just curious, you talked about mobile CDN being like a much harder problem to solve.
Mm-hmm.
Could you like just briefly explain why that is, and like how you would kind of start transitioning over to something like that in the future?
Yeah, so the reason why mobile is harder is that these are much smaller devices. The type of connection changes a lot. So for example, the profile of a mobile phone is very different when it's at home, plugged in a Wi-Fi network, plugged into the wall. So that means like it has reliable power and reliable internet, and probably not a bunch of use from the human, because the human's probably asleep. So then at that point, like the mobile phone is good, but that usually is at night when other people around are probably not using the internet very much, and so other people elsewhere in the world might be using it. You also have like, if you now deal with mobile phones when they're in your pocket and you're moving around and so on, now you're dealing with like connection changing because you're going across Wi-Fi networks to mobile networks, mobile internet networks, and so on, which means like a bunch of like connection tear down and reset up, and the phone itself, depending on the carrier, may or may not be getting a different IP, which for overlay networks and peer-to-peer, like that's really hard. So you deal with like, so you have like these massive networks with like nodes with tons of churn, so they're coming in and out all the time. They're not that big. You can't put that much storage in them relative to a home computer or something like that. And the internet connect and the bandwidth is not as good as some home bandwidth. And it's also very expensive. Like if people sort of like screw up their setup, they might be like charged tons of money for serving this. So it's just like a much harder product landscape. And so I would say like get it working really well first with home desktop type computers and with like data center, small like single server machines. When you put like a ton of drives in like one server, or a few, and like that's kind of like the best candidate target for retrieval markets today. That's easiest. Get that working, then from there you can then solve the hard problems of the mobile network. That's my guess though. It could be that someone like focuses on those problems really well, finds a narrow use case. Maybe it only works when you plug it in. Maybe it only works when you go to sleep, you open an app, plug it in, and like leave, and then maybe it works. But like again, I think you'll get more storage and better internet access from these other kind of like dedicated machines. Yep.
Just sort of adding on to that, because you also mentioned Netflix. I was wondering if you could add more color to how Netflix and or YouTube manages mobile CDN, if you had any insight there.
Yeah. Is this it? So the kind of like perspective is that this is sort of like a map of the internet, and so you have this grapevine behavior. It's not very easy to look at it here. Maybe these diagrams are better. Like this is like a map of the internet. You zoom in. This is sort of like what the grapevine looks like. Here's another way to look at it. So you really want the content distribution to travel as few hops as possible, but you can't move all the content that's in like that densely connected interior out into the edges. So you kind of want to be adaptive. And so then the way that Netflix does it is that they're kind of like in a content provider spot over here, and then their users are consumers in homes or offices, and that path is really expensive for them. And so what they ended up doing was for a long time they shipped racks of drives to ISPs. I'm not sure if they're still doing this, but they preloaded these machines. This is part of the reason I knew that things like IPFS with content addressing and things like Filecoin were gonna work is because companies like Netflix do this. They would identify which movies were the most likely to be watched in a specific area, and they would then preload them into drives and ship that, and then do kind of in the background updates to those machines asynchronously from like the user's perspective. This would be kind of like a background process, updating the catalog in here. And then these machines would be sitting right there in the ISP, very close to the home users. So that becomes like a super fast hop, right? Like that becomes kind of 4 to 20 millisecond round trip, and like that's phenomenal. And there's like a set of great talks from the Netflix team talking about kind of various different things that they've done to their architecture. One of them, I know that even for like their APIs, they do this like, they don't want individual connections set up every time. And so that even for their APIs, they kind of have like this bastion node that your consumer like connects to, and then from there they send requests out, and all of those requests get proxied from that node out somewhere else. And that node is like, depending on their service, that might be close to the user, or that might be in a data center somewhere, but it kind of gives you kind of this much more stable look from the user, as opposed to getting a phone to kind of open tons of connections to different machines and so on. So they really kind of took an overlay network approach to this, where they kind of like set up a connection, maintain that connection, and push as much traffic as they can through that. And other important thing, Netflix very much separates the application stuff from the content. So the movies get distributed by a completely separate system than the static assets of the page. So like these static assets that are involved in the web apps or the movie catalogs and so on, all those little files get distributed by a different system than the movies themselves. Because it's just, you end up with like different requirements, and so you want software that like is just tuned for the specific use case. Yep.
Is there anything working right now, or anyone working right now on like mobile apps that you just leave online during while you sleep, which would be like awesome?
Yeah, I do think that this kind of thing exists. I haven't done a review of the app stores to find them, but I think somebody has done this. I don't think we've been the only, because I've discussed this with a few people. I don't think we've been the only people to kind of think about this. So I would bet that some exist. I know that some people in our network want to go do this. It's just they haven't gotten around to it.
So we talked about mobile, like cell phones, being a very like not optimal candidate for delivering data, and stations at home being very optimal. What about laptops, which also frequently change places, are switched on and off?
Yeah, I think laptops are also not great candidates for that reason. I think a laptop is probably better than a phone. So it would kind of, if I were to kind of change this diagram here, I would add a laptop and then a phone all the way to the left, and say that the best type of nodes for now are like these. This is kind of like the sweet spot of where you want to be. So the thing on the left is not a laptop. It's just like a home desktop, or like a NAS, like a network attached storage device. And those, I think, are like the ideal candidates because they usually have somewhere between half a terabyte to 10, 30 terabytes in the larger case. And then these other, then you have a lot of people who either in data centers or at home with fast connections deploy like little server racks, either kind of like a small system with somewhere between 10 to 100 terabytes, or some larger systems with full petabyte. So there's a lot of people out in the world that have that type of storage, and they're not using all of it. And so that's like perfect candidates to kind of preload tons of content in there and then serve it from there. You just have to kind of route the request to them well, which is kind of why the two-layer architecture, I think, works really well. You want to preload a bunch of content and have it cached there, and then kind of have a different set of nodes that are dealing with the bandwidth. Cool. All right. Thank you very much. Sorry for going over.